Okay, everyone, in this video here, I want to take the time to show you guys how to solve, the mathematical steps needed to solve for the horizontal distance of each cannonball in this particular ranking task. Now, notice that the mathematical steps needed in this particular worksheet here, those mathematical steps will be slightly different from the mathematical steps that we took in this worksheet here. In this worksheet here, in every situation, we were releasing our objects horizontally. In other words, we were releasing our objects straight on. So, for example, consider the cannonball. If I have a cannonball here, notice how the cannonball is being fired horizontally. In other words, it's being fired straight on. It's not being fired at an angle. But notice that's a different situation compared to this here. In this situation, I can fire a cannonball at an angle instead of just firing it straight on. I can vary my angle here. I can fire the cannonball at 45 degrees, or I can fire the cannonball at 60 degrees, or I can even see what happens if I fire the cannonball at 90 degrees. In other words, I'm firing it straight up. So notice here I'm varying my angle compared to this situation here in which I was firing it straight on horizontally. So that's what we're concerning ourselves with here in this ranking task. We're going to be working through the mathematical steps needed to solve for the horizontal distance as we vary our angles in each particular scenario. So be sure you're following along and you're showing me your work. Now, let us look at situation A. In order to find the overall horizontal distance the cannonball travels when it is launched, will involve 4 major steps. Let's begin with step 1. In step 1, what you have to do, you have to take this velocity vector here and you have to split it up into its x and y components. You want to know how fast is this cannonball moving in the x direction when it is launched. So the initial velocity in the x direction. You also want to know the initial velocity in the y direction the moment it is launched. Now, if you notice, they gave us the initial velocity in the x direction. They told us the cannonball was moving at 20 meters per second the moment it was launched. They also gave us the velocity along this hypotenuse here, which is 23.1 meters per second. So the question is, what is the initial velocity in the y direction? How do we solve for that? How do we solve for this vector in green? Well, it's easy, because if you look at that vector, you will notice that it's opposite that angle of 30 degrees, which means we need to use our sine function, because the sine of some function, the sine of some angle, theta, is equal to opposite over hypotenuse. So I'm going to write that down here. So the sine of 30 degrees is equal to our opposite side, which is our initial velocity in the y direction, divided by our hypotenuse, which we know is 23.1 meters per second. Okay, so in order to solve for the initial velocity in the y direction, that's easy. That's just basic algebra. You would just do 23.1 times sine of 30 degrees. And if you put in your calculator, do the calculations, this is what you're going to get. You're going to get 11.55 meters per second. Okay, so that's how fast that cannonball was moving in the y direction the moment it was launched. So that's step 1. Find the y component of the initial velocity of the cannonball. So now let's move on to step 2. Step 2 says, find the time it takes for the cannonball to reach the very top of its trajectory. So let me draw out this picture here, how this is going to look like. When the cannonball is fired, its path of motion is going to look something like this. It's going to go up, then it's going to come back down. Okay. So the question is, in step 2, how long does it take the cannonball to reach the very top of its path? How long does it take to reach the top? Okay. So in order to solve for that, we're going to need to go to our kinematic equations. So specifically, we're going to use this first kinematic equation right here. this equation says that the final velocity is equal to initial velocity plus acceleration times time. So that's the equation we're going to use to solve for this. So I'm going to write that down here. So final velocity is equal to initial velocity plus acceleration times time. Now, in order to solve for the time it takes to reach the top of its trajectory, we're going to just solely focus on what's happening in the y direction and looking only at the y direction. Because remember, we're treating y as if it's independent of x. So we're going to focus on y first, and then by the time we get to the end of this problem, we're going to look at x. But focusing solely on y, remember, this cannonball, the moment it was launched, had an initial velocity of 11.55 meters per second. Okay, so that was the initial velocity of the cannonball. So that means right here in this equation, we're going to plug in 11.55 meters per second for initial velocity. But what about our final velocity? Well, the final velocity, that's easy. Think about this logically here, guys. What is the final velocity of that cannonball the moment it reaches the top? That's what we're looking at. We're just solely focused on the time it takes to reach the top here in this step. Well, if the cannonball goes up and comes back down, it has to come to a stop first. So that means that its final velocity at the very top is just 0. So it's moving at 0 meters per second at the very top. We just see it that its velocity was 11.55 meters per second the moment it was fired. What about its acceleration? Well, that's easy. Since we're solely focusing on the y direction, there's only one force acting in the y direction, that's gravity. So that means the acceleration has to be negative 9.8 meters per second squared. And of course, it is necessary that I put this negative here because I want to show that the sign of the acceleration is opposite that of the initial velocity. So that's why I put that. Now, the rest is just algebra to solve for t. So, because that t there represents the time it takes to reach the top. Okay. So in order to solve for t, I want to take this negative 9.8 times t, and I want to move that to the other side of the equal sign. In order to do that, I need to do the opposite of subtraction, and that is to add. Plus negative 9.8 times t, that goes away, and whatever I do to one side, I have to do to the other. So therefore, I'm going to get a 9.8t on the other side of the equal sign is equal to 11.55. And the last thing that we want to do here for this step is to get t by itself. So that's easy. Just take this side of the equation and divide by 9.8. And so that goes away. And remember, whatever we do to one side of the equation, we have to do to the other. So we're just left with t is equal to 1.17 seconds. Okay. So that right there represents the time it takes for the ball to reach the top of its path. Now, let's move on to step 3. Step 3 says, find the total time the ball is in the air. Well, that's easy. If we want to know what this time is right here, just look at the picture here and think logically. The time it takes for the ball to reach the top of its path here is half the time that it takes for the ball to travel the entire distance in its trajectory. So that means in order to find this time here, all we need to do is take 1.17 seconds and multiply that by 2. So for step 3, again, total time is just equal to 2 times 1.17 seconds. And when you put that in your calculator, you should get 2.35 seconds And that right there represents this time right here, the total time the cannonball is in the air. And now that we found that, let's move on to our last step, the fourth step here. And this is, in this step, you're going to use the displacement equation to find the total horizontal distance the cannonball traveled. So, now, in order to find the total horizontal distance, which is the distance from here to here, that's easy. All we need to do is to use our displacement equation here to find that. So I'm going to write that down. Write down my displacement equation. Okay. So displacement is equal to initial velocity times t plus 1/2 at squared. Now, guys, remember what we said here. In order to find this horizontal displacement here, we need to solely focus on what's happening in the x direction. And remember, there are no forces acting in the x direction if we ignore air resistance. And gravity, the gravitational force in the y direction, has no impact on what's happening in the x direction. So that means if we have no forces acting in the x direction, that means our acceleration in the x direction is equal to 0. Okay? And if our acceleration is equal to 0, so if I take 0 here and plug that in here, that means this part of the equation goes away. And so what I'm left with is displacement is equal to initial velocity times t times time. Well, as we see here, we're given the initial velocity in the x direction, which stays constant. So the initial velocity is 20 meters per second. And we just found the total time the ball is in the air, the total time in free fall. So all we do is just multiply those two numbers to get the horizontal displacement. In other words, the distance in the x direction. So distance is equal to initial velocity of 20 multiplied by the total time the ball is in the air, 2.35 seconds. And then when we multiply those together, what we get is a displacement of this, somewhere around 47 meters. Okay. And that is our displacement for situation A. Wait, I want to say this before you guys work out the rest, just to save you some time. I want you guys to notice something. Notice situation B. Situation B is very similar to situation A. The only difference is the mass here is 4 kilograms and the mass in A was 2 kilograms. But guys, question, does mass have any impact on the acceleration of gravity? Remember we talked about that at the beginning of the school year. No, it doesn't. So if mass doesn't have any impact on the acceleration of gravity, that means the distance traveled for B has to be the same thing as the distance traveled for A. Okay, so keep that in mind. Hopefully that should save you some time whenever you guys are solving these problems. So you don't have to go through the math for B because you already know what that answer is. All right, so if you guys need some help, please contact me.